Hello, welcome to today's video. We're going to be talking about systems and surroundings and how those things impact our study of thermodynamics in chemistry. So the first thing we have to talk about is what is the system, what is the surroundings, what is all of that? And the cool thing about this is that you get to choose. So a lot of things in chemistry are already picked for you, but in this case, you kind of have a little bit of choice in how you define certain things, and it'll change signs and it'll change how you approach the problem, but you get to pick, which is a really kind of a handy trick. So if we see here, we have our system. So anything that's in blue is what we're referring to. So the system in this case is this Erlenmeyer flask with our liquid in it. Actually, more specifically, just the liquid inside the flask. So if we look, just that's in blue. And then we're going to refer to that as our system and everything with respect to that liquid inside. Now we can see in the second one that the box that the liquid's sitting in and the flask that the liquid's contained within are going to be considered surroundings. So that's everything else other than our system. So in this case, the box and the flask, but in reality, in any question we do, it's everything else outside of our system. So then the other term that scientists use is the universe. So that's everything in the problem. So I'm going to put that in quotations because technically they are referring to the entire universe, but practically that's not really how we're going to approach a problem. So in this case, the universe is basically only going to extend to the box and the flask because everything else is going to be so minutely impacted that we're not really going to be able to measure it. That's a brief overview of what system, surroundings, and universe are. So now, if we look down here, we have a couple different kinds of systems. So we have isolated systems, closed systems, and open systems. So an isolated system is a system in which you cannot exchange matter and you cannot exchange energy. So I like to think of it like a Yeti cooler, like those big white coolers that are really, really good, because the idea is that heat cannot get in and out. And if you keep it closed, nothing inside gets out, nothing outside gets in. So it's completely isolated. There's no heat and there's no matter. There's no stuff being exchanged through the both of them. The next one is a closed system. So it's the verbiage is a little weird because closed and isolated make them sound really similar. But a closed system is no matter can be exchanged, but you can exchange energy. So I like to think of that almost like a sealed coffee cup. So if you go to Starbucks and you get a paper cup and they put a lid on it with a little plug, no liquid can get in or out, but the cup is still hot because you're feeling the heat from the inside escaping. And then an open system is like your cup of soup. So you can add soup, you can take soup out, you can do whatever you want, and you can see the steam coming off of your soup. So it's losing heat to the world, or if you say put it in a microwave, it's gaining heat. So that's what an open system is. So now we've defined system and surroundings and talked about a couple different kinds of systems. Let's talk about how we measure what's going on. So if we look at this picture, we always measure, with the system. So we see here energy out, we have a negative sign, energy in, we have a positive sign. So if the system is giving energy off, we give the energy a negative sign. But in reality, what does that mean? It means that our system is giving heat to the surroundings. So if we feel something and it's hot, that's what it is. So energy is leaving, we give the system a negative sign. Energy going in, we give the system a positive sign because we're putting energy in. That would be if something felt cold. Your hand is putting heat energy into the system, which is why it feels cold. That sign system is backwards to what a lot of people think initially, but the more you work with it, the more comfortable you'll get. And it'll make a lot more sense the more practice problems you do using a negative sign for a system losing energy. And what does that look like graphically? We have a little example down here. So we see here that the delta H of our reaction is less than 0. So we have negative energy, so delta E is negative. You'll see delta H very soon, and then we have delta E is positive over here. So that, as we see, heat is going from the system to the surroundings. Here we see heat going from the surroundings to the system, and scientists give these fancy names. This one's exothermic, so it's losing heat. Exo, giving off outside, thermic, heat. Endothermic, endo, obviously opposite, going in, thermic, still heat. And we have heat energy entering the system. There are other ways that energy can enter and exit, but the predominant one you'll see here is heat, which is why they use delta H. So delta H is just a measure of heat energy. So I hope that gives you a quick overview of a thermodynamic system and surroundings and energy transfer, because we'll be using this a lot in your class, and any future classes you take in chemistry or physics or even biology, you'll probably see something like this. I hope that helped.